Have you ever wondered what might lie at the end of the universe? It's amazing to imagine what it could be like at the very edge of the universe, what it looks like, what is out there. If it were possible to see this part of space, we would see the beginning of the universe as it began. But once something slips past the event horizon, it becomes lost to our sight, no longer giving off light signals. Space-time is a fascinating subject, one that needs to be explored to fully understand just how big the known universe is. So let's take a journey to the outside of the known universe and answer, what happens at the edge of the universe? The beginning of the universe is said to have begun with the Big Bang. In the beginning, the cosmic microwave background used to be orange. So yes, space was the color orange for billions of years. The universe is a vast place, probably much bigger than the mind can accept. In fact, the argument is that the universe is infinite. However, if you were to measure the radius of the edge of the observable universe, it would be 46 billion light-years in radius, which equals 93 billion light-years in diameter, end to end. We say observable because light from anything out further hasn't reached us yet. And for those who don't know, a light year is the distance that light travels in a year, which is 9 trillion kilometers in a year. The distance is measured by using something called cosmological redshift. It is the fingerprint that expansion leaves on beams of light. To make it simple to understand, the longer a wavelength of light, the redder the light will be. Blue would be shorter, so if space wasn't expanding, then light from a distant galaxy would be the same color. So what is out there that we are able to see? At the end of the universe is what is called the particle horizon. It is the current instantaneous distance to the most distant part of the universe. In other words, it is the most distant part of the universe that could possibly have had a causal connection to our own galaxy. So anything inside this particle horizon is referred to as the known universe. It's also important to understand that current instantaneous distance would be the distance you would have to travel if the universe expansion were frozen, meaning you were traveling through static space. It would be the only way you could get to the end of the universe if that were possible in the first place. Before we go any further, it is important to understand that the particle horizon and the cosmic event horizon are two separate things. What is strange is that the event horizon is closer to us than the particle horizon. It is estimated that the cosmic event horizon is about 16 billion light-years away. What this means is that there are galaxies that we can currently see that we could never reach. But here is the problem. The shortest path in space-time is defined or measured by geodesic. Geodesic is the shortest possible line between 2 points on a sphere or other curved surface. So we can say the path of light between 2 points. Most people know that it takes time for light to travel. If you didn't know that, it takes about 8 minutes and 20 seconds for the sun's light to reach us, for example. So we have to factor in the time interval, especially when space is changing with the expansion of the universe. With that being said, to travel to the particle horizon, the known edge of our expanding universe, by the time we covered the known distance, space would have expanded over the remaining distance. So how far would you have to travel? You would have to travel infinitely far, even if you had a spacecraft that could travel the speed of light. So let's talk about space travel for a moment. We know that black holes have event horizons. That goes the same for the universe. An event horizon is defined as the point where we can no longer receive information because light from that point has redshifted into oblivion. This event horizon is the boundary to our observable universe. There is a region of this universe from which we can never receive any new signals from. This means any signals of light that were emitted today would not reach us because that signal would have to travel towards us from an expanding universe. That distance that signal has to travel to get to us will be expanding faster than the speed of light before the signal reaches us. It would be the same in the opposite direction. So the same thing applies to our light-speed spacecraft. We can never get to anything beyond the event horizon because that space will be moving away from us faster than light before we could reach it. What is even more mind-boggling is that we're seeing what could be called ghost images. Consider any light that we see from billions of light years away. If it took billions of light years to get to us, then it's very possible that that object that gave off the light doesn't exist anymore, or has moved outside of the particle horizon. As the universe keeps expanding, more and more of it will cross the event horizon. And in case you might be confused about the difference between the event horizon and the particle horizon, the event horizon is easiest to think of as the point of no return. It is a boundary in space-time beyond which events cannot affect an outside observer. The event horizon is that point, and each day more of our universe slips past this point. Everything inside our universe will eventually cross this point. But would it be possible to travel there? If it were possible to break the barrier of the speed of light, which is 186,000 miles per second. According to Einstein, nothing can travel faster than light, and only light can travel at this speed. And it would take an infinite amount of energy to propel any material object at this speed. An accelerating object gains mass, and this becomes heavier, and the faster the object travels, the more massive it becomes. But this is for objects moving through space. We could try to break this cosmic speed limit, and in fact are already trying to do just that. Superliminal motion, which was first observed in 1902 by Jacobus Kapteyn, who witnessed the ejecta from a nova, not to be confused with a supernova, GK Persei, which exploded the previous year. Superliminal motion is the apparent faster-than-light motion that is seen in some radio galaxies and quasars. These sources are thought to contain black holes that eject matter at high velocities. Superliminal speed is actually behind the motivation of the warp drive. So let's assume we have a warp drive-capable starship. First of all, we would have to burn the mass energy of entire stars to power the warp drive. If we were able to get to the particle horizon, we would likely see more universe. Don't forget that the particle horizons set the limit for our current view. But if we were to get out there and look back to our universe, it might appear as a newborn universe on another particle horizon. But what if we keep going? On the largest scales, the geometry of space-time is very flat. On smaller scales, it has ripples due to stars and galaxies. Think of it as ripples on the ocean. Measurements of the distributions of galaxies and the cosmic microwave background confirm the flatness with a very high, but not infinite precision. With that being said, if space-time really is flat, then the universe is infinite, meaning that the universe just goes on forever. There are many types of infinity, including some that involve infinitely repeating versions of this universe. The big question is our universe really perfectly flat? The Earth seems like it's flat and you can't see the curvature until you take a ride in the International Space Station, where you can clearly see the curvature of the Earth. It could be possible that the curvature of the universe is so small that we are either not seeing far enough or measuring precisely enough to detect it. It's quite possible that the universe does have curvature. If the curvature is positive, then maybe the universe is the surface of a hypersphere, or the 3D surface of a 4-dimensional sphere. If this was the case, our warp ship would travel all the way around this hypersphere and eventually travel back to where it started from. Although the theory of general relativity is regarded as the standard, it isn't the theory of everything. This is actually where the idea of the multiverse comes from. Some ideas suggest that our universe may be a bubble in an exponentially infinitely inflating multiverse. And if there is an infinite amount of universes, and even ones like ours, there could be many possibilities. There could be planets just like ours, with a copy of someone that looks just like you, living in an alternate universe billions and billions of light years away. It would be interesting to see warp drives become a reality and have the ability to travel to the farthest reaches of the universe. We understand more and more each year as technology advances and humans become smarter. Telescopes become more powerful. Space travel is becoming more of a reality each day, with an expedition of Mars currently in our sights. It is possible that one day, nothing will be impossible for us. We hope you enjoyed this video. Did we forget anything? Tell us what you think in the comments below.